Well, welcome back here to the Air Crash Investigator. Today I'm going to talk about Cirrus SR22 that did a balked landing. Now, a balked landing is normally a landing that went wrong, and then after that the aircraft has to go wrong. In other words, you cannot continue with a landing that is, we've got to stop this landing thing right now. All right. But before I carry on, just a reminder again that I'm closely working with these guys from Seams Aircraft Auditing and from Seams Training. And you will find the information in this description below. Well, while you're at it, you might as well like it and just be part of us. All right, then the SR22, unfortunately, this landing was a balked landing. Now, it happened at Nelspruit. I need you, especially if you are a Cirrus pilot, if you are a potential Cirrus pilot, just to pay a little bit of attention. It is maybe a small difference, but it's got huge and big ramifications. Right, so let's have a look at the history of flight. And I say the pilot flew to the Nelspruit Airport. He planned an approach on runway 04, which is in that direction. And there were two other aircraft in the circuit, but they were running for runway 22. Now, you will say, but the wind was from the rear. But remember, this is a very sloped runway. And when you go and look at the plate, the landing plate of this airport, then they will tell you under circumstances you must land here and you must land there. And under these conditions, runway 22 was definitely the preferred runway and should have been used. And in fact was when the wind was 3 to 9, 10, gusting 20 to 25. It's very difficult. So when you look at what is the wind now, what did the wind indicate, and what was the predictions, and what was it really on the ground, this is the closest that I could get to finding out what the wind was. Now 3 to 9, 10, gusting 20 to 25, hey, that's bad news. Because here you can see the wind indicator that I've got. Well, let me make it a little bit bigger because I'm in the way. Here you can see the wind indicator. And here you can see that the wind is blocked off. So the moment that we get around about in this area here, we've got a serious problem, even below, because there's a lot of trees and stuff on the right side here. So a wind from this side, especially if there's a gust, now you've got wind speed and now you don't have wind speed. It is not a nice situation to be in. All right, the runway 22 slope favors the landing except for strong southerly winds. The pilot flew 7.6 hours last 90 days, of which 4.4 on type. A pilot is not rated on the type. Okay, whoa. The pilot did not have the SR22 on his license. He had been flying, so he had to have some sort of deal, but I don't think the paperwork was completed and sent in. Now, in other episodes, I've said that a license is but a piece of paper and capability is what it's all about. The license indicates that you should have the capability, but it does not guarantee that you have it. Now, the Cirrus, listen closely, if you want to do a Cirrus conversion, because it's a different wing type than the normal Cessnas, Cherokees, and the normal stuff, the Barons, and the aircraft that we fly. It's a more high-speed wing, but we'll get into that. But you need very proper training, especially when it comes to the stalling characteristics. So, for no moment do you think there's anything wrong. This is a beautiful machine. I love it. A strong crosswind landing was observed. The other two people that has just landed, they observed this. We clean up a little bit. and it was a very hard landing followed by full power. Now, the landing itself coming in, already the aircraft drifted a lot to the left, and then at one moment it is just like all the lift was out of the sky. Now that could do a lot with technique, that could do a lot with the wind, and there is a technique how to compensate for this wind, and that is now, besides that the aircraft is now in that area where he must go around. So this is then what we call a Balked landing. The landing with full flap is required, no retraction on go around. Whoa, wait, let me just get this one straight. It is critically important. It is more critically important in this design wing than it is in any other normal Cessna, Bonnie, whatever you fly, all right? And the reason is that because of the sleekness and the wing tip, they couldn't wash it out enough. So when you re-energize by putting full power, the inboard section is now quite a distance from the critical angle due to the wash from the propeller. But the wing tips, and we've always been worried about wing tip stalling. With full flap in the Cirrus, wing tip stalling is real. That is why the manual for procedures say to you that you've got to take off from landing flap, or they call it 100% flap, to 50% flap, which will then make that the main wings still has got the probability and possibility, if it stalls, to be before the wingtip stalling. But if you do not pick up those flaps, go and read the pilot operating handbook. So there was a turn to the left before the fatal crash. Now there could be a lot of reasons to turn to the left. The propeller is turning, so it's hitting the horizontal rudder fin from the left. It pushes the nose to the left. So these are things that we expect to happen. So the aircraft drifted left. As it gets airborne, it left wing low, and the pilot tries. But remember, as he starts turning left now, he's turning onto a downwind. It's not that he wants to. The pilot can do nothing about this situation because of the full flap that is there and the rise of the ground. I'm sorry to say, but a recovery was not possible. Now, again, looking at causation possibilities, because that is what we discussed. Although high general flight hours of the pilots, very few on type, I haven't got a problem with a few hours on type. There's types that I had no hours on when I started flying with them. Okay, there's similar types and all that kind of stuff. Do you know one thing that I do is I make damn sure that I understand the characteristics of the aircraft that I'm going to fly. And I would venture the possibility that pilot was never taught the characteristics of a higher or a semi-higher speed wing, which will have, it has drastic consequences. It behaves different from the normal day stuff. Stalling characteristics of the wing differs from the normal aspect ratio, and I said it there. Wing of a semi-high speed design outboard section different from the inboard. Inboard section re-energized full power with full flap as required for landing. The stalling angle of the outer wing reaches critical status before the inboard section. I've said that now. And the power operating handbook state that inclusive of bolt or go around must be done with take-off flap. Okay, the book states the following. You will take off with take-off flap. Always. Irrespective of the wind, you will land with full flap. This aircraft has been tested up to a 20-knot crosswind. It's high enough. 20-knot crosswind is a lot. You need to understand how to do things. If you want to land a light aircraft in a 20-knot crosswind, man. All right. Okay. High nose attitude. Sorry. Here we go. Let me get rid of that. Aileron usage with a low wing close to the stall will increase the probability of the low wing reaching stalling angle sooner. Think of that. The left wing is low. You want to pick it up with right aileron. The left wing aileron goes down. It increases the outboard section's angle of attack. And if it has not reached critical angle yet, you have now put it onto the critical angle step. Only way that you can pick up a wing then is by with the radar. But anyway, okay, high nose attitude could not be lowered down to the trees, and the slopes opposite with rudder could help to pick up the dropped wing. The pilot probably did not know about a phenomenon during his conversion. The phenomenon I'm talking about is the fact that the stalling speed of the aircraft with full flap and full power is higher than the normal 50% flap and full power. The stall speed goes up, not due to any reason, but the wingtips now get into the stalling region. It's not a design fault, please. It's a high-speed wing. When you land the Columbia, you don't pull other tricks. This is how you land it, and that's it. You don't get away with it. The high speed and high aspect ratio favored a more positive landing from the approach, from the strong crosswind. I'm slightly saying now that in very strong conditions, and then there's possibilities of a cutoff of wing, you've got to be aware of those situations, and then you want to get into ground effect on the center of the runway. You can stop the drift with ailerons, and one of the facts is once you're on the ground, you can retain and maintain your direction with differential braking. That means slightly higher speed, and you fly onto the runway. If you are 3 foot above the runway and in the center of the runway, and you close that power, it is no problem if the aircraft falls out of the sky. None so ever. As long as the longitudinal axis of your aircraft is aligned with the longitudinal axis of the runway. You can't land it like the Boeings. Okay. The technique of not drifting off center line during a crosswind landing with ailerons and directional control with rudder could have played a role. And yeah, a lot of people say you crab it in and then you kick it straight. I fly a lot of these in crosswinds. Before I get to the runway, I want to understand, have I got enough aileron to stop the drift? And have I got enough rudder to maintain the center line? I cannot find out they don't work at number 99. It's light aircraft, cannot work. The momentums is very low, therefore the moment that the tire grabs the tar, it will set off in a direction that I do not want it to go necessarily. Okay. Now let's just have a look here at the aircraft design composition. Well, what I've done for you here is I've taken the Cessna 172 and the SR, and I literally cut them in half, and you will see here these are exact sizes in comparison, okay? And you'll see that it's a little bit of a longer tail section here with the C172 In fact, it's a couple of centimeters. I've got it here. There it is. It's 28 centimeters longer, but it's there in the tail section. But look at the tail section size and look at the size. Look at the size. Look at the size. Look at the aspect ratio. Look at the aspect ratio. All right? These are different wings on the same typical size and shape aircraft. Yes, the Cirrus is built for high speed and it's high quality. And it needs certain techniques to take off and land, and anything else is not going to work. You cannot blame the aircraft if you did not follow the rules. So read the book before. Do not read the book if all else has failed. You might have... All right. Okay. Although the stalling speed differs at least 10 knots, the difference lies in the inner section after full power. In the outstalled, and I've said there, with 100% flaps, due to the wing design and not a design error, but a different design limitation to make the wing capable of higher speeds at less drag. Quite noticeable is also the horizontal tail of wing, indicating a lower control speed capability of the 172. Okay, the aircraft are designed for higher speeds. Other limitations will occur which, if not trained for, can catch the pilot off guard. And this is what we're talking of. With 50% or takeoff flap, the tip stalling condition is not experienced under normal operating conditions. And therein lies the answer. So what are the lessons that we are going to take away? First of all, every aircraft wing design requires a different technique under normal conditions. So we keep the conditions the same, the wings are different, and therefore the handling of the wings in the same circumstances must be different. And that becomes, you cannot live, there is no generic how to fly this wing and that wing and that wing and that wing. Okay, that's one of the things. To get the best possible training is worth, let me clean up there so that you can see that one properly. I say, to get the best possible training and type is worth a lifetime. Remember that saying. The best possible training on a type is worth a lifetime. It speaks for itself. The aircraft pilot operator is an absolute guide. The aircraft pilot operating handbook is the absolute guide to operating the aircraft, and a general idea is just not good enough. A general idea is not. Flying under normal conditions are easy, and most people just naturally able to do straight and level. Only well-trained and people on type, as well as the application-specific training, can increase the probability of success flight, even under poor adverse conditions. Landing accidents are by far. I need to attract more attention for this last statement here. I can statistically show you that landing accidents are by far normally due to the inability of the pilot to handle the aircraft in crosswind conditions. So when I talk about the general reasons, light aircraft, the biggest reason for light aircraft accidents is on approach and landing. That's where they crash. Okay? Why? Everybody blames the wind. Okay? So have we ever learned how to fly in crosswind conditions? Because it is sort of ludicrous to think that the wind is going to be the same now, and an hour later it's going to be the same as an hour in the past. It's not. Okay? All right. So let's calm down a bit. Let's pay attention, and see you in the next round.